Hi everyone, welcome to my channel Triple Encyclopedia. And in this video, let us see about Millman's theorem. In the network analysis, the normally available theorems are Thevenin's theorem, Norton's theorem, maximum power transfer theorem, superposition theorem. These four theorems are very important theorems while analyzing the complex circuit. And apart from that, this Millman's theorem also one of the important theorem in circuit theory. So now let us see about the Millman's theorem. The Millman's theorem is normally given by Jacob Millman, and the utility of the Millman's theorem is that the number of parallel voltage sources can be reduced to one equivalent source. That is, the number of voltage sources are connected in parallel means that a parallel combination of more number of voltage sources can be replaced by a single voltage source. So now let us see how that number of voltage sources are converted into single voltage source by using this Millman's theorem. So according to the Millman's theorem, the statement is nothing but when a number of voltage sources, that is V1, V2, V3 up to Vn, are in parallel, having the internal resistances R1, R2, R3 and Rn. Okay, so now that number of voltage sources with internal resistances are replaced by a single equivalent voltage source V in series with the equivalent resistance, right? So just to see the example, so here this is the circuit is having V1, V2, Vn, that is there are n number of voltage sources are having the internal resistances R1, R2 and Rn, and again it is connected parallel with the load resistance RL. So this is the number of voltage sources. This is converted into a single voltage source with only one internal resistance. So here this portion is having the voltage sources V1, V2 up to Vn and having the internal resistance R1, R2, Rn. These are all in parallel. So the parallel combination of more number of voltage sources are replaced by a single voltage source with the internal only one resistance R. Again, the load resistance will be connected in parallel across the equivalent resistance and the voltage, and finally current flowing through the circuit can be obtained. So now if you are replacing the number of voltage sources into single voltage source, how it will be reduced into a single voltage source and the single resistances? Just we are applying the formula according to the Millman's theorem. So in the equivalent circuit, the value of voltage V is nothing but plus or minus. So depending upon the polarity of the voltage sources, if it is a plus minus like that, means automatically in the equation we are using the plus V1 G1. Suppose the polarity may be changed in that given circuit, means we want to use the minus V1 G1. So here G1 is nothing but the conductance of the circuit. That is, conductance is nothing but inverse of resistance. 1 by R1 is called as the conductance. Just take the inverse of the resistance so that we can get the conductance value. And second plus or minus again voltage source with the second resistance inverse, that is called G2 up to Vn value divided by 1 by R1, that is G1 plus G2 plus up to Gn. So this is the formula for getting the equivalent voltage source at the circuit. That is, in the equivalent circuit, this voltage voltage source formula is nothing but this one. And in the same circuit, what is the value of R? How to get the only one resistance value from the n number of resistances, internal resistance in the given voltage source? Just apply this formula. R is equal to 1 by G, which is equal to 1 by G1 plus G2 plus Gn. That is, G1 is nothing but 1 by R1, G2 is 1 by R2, and G2 1 by Rn. So like that we can get the equivalent voltage and resistances in that final equivalent circuit. So now let us see the steps for solving the Millman's theorem. Okay, suppose the circuit is given, it is having the more number of voltage sources and it is having the internal resistance R1, R2, Rn, means how to reduce that circuit into single voltage source with the single internal resistance by applying these steps. So first one is the obtain the conductance. Just initially we want to calculate the conductances. Just we are taking the inverse of resistance 1 by R1 G1 and 1 by R2 is the G2, and for each voltage source is V1, V2. Second step, find the value of equivalent conductance G by removing the load from the network. Just we are removing the load resistance in the given circuit and just calculate the equivalent conductance value. So now we are going to apply the Millman's theorem. Find the equivalent voltage source value. V is equal to, already previously we have seen this formula. And next step is to determine the equivalent conductance value, that is series resistance. R is nothing but inverse of the conductance value 1 by R1 plus 1 by R2 plus 1 by Rn. So after getting the value of VR and IR in this circuit, so here we are getting the value of V and R. and we know the value of RL. How to find current flowing through the resistance? Just apply the Ohm's law. I is equal to V divided by total resistance of this circuit. I is equal to V divided by R plus RL. That is the current flowing through the circuit. IL is equal to V divided by R plus RL. So instead of reducing instead of applying the formula here, if you are applying the formula IL, it is somewhat complicated to get the IL value by using the more number of sources. So instead of that, these more number of voltage sources are replaced by a single voltage source, and just we are applying the simple Ohm's law, and we can get the value of current flowing through the load IL. So this is about Millman's theorem. So it is also an important theorem. So many number of questions are asked in the competitive exams by using this theorem. Okay, thank you for watching. If you are new to this channel, kindly subscribe our channel AAA Encyclopedia, and share all basic concepts of this channel to your friends also. Thank you for watching.